All right, so with this lesson here, we're going to be dividing multi-digit numbers using an algorithm. And so we'll do it longhand for a little bit. We'll also use that algorithm to kind of give us that information we need to do the longhand a little faster, but then also we're going to estimate too, and that's the key here. We're estimating. So from our prior lessons, we talked about how to do some rounding and then some estimation. So I'm going to round this to 70,000, and I'm going to round this to 20. And so now we have an estimate of 70,000 divided by 20. We know that we can cross out the zeros, and I'm left with 7,000 divided by 2. And half of 7 is 3.5, so 3,500 would be our estimate that it should be approximate to, or about 3,500. And what we're going to do now, using an algorithm for this, is we're going to look at multiples of 9. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, we wouldn't do 10, because 10 then means that, it could fit in with a 1 and then continue on. So we're looking at multiples of 9. So I have 1 times 9, which is 19, and 2 times 9, which is 38. 3 times 9, which is 57. And 4 times 9, which is 76. And 5 times 9 is 95. And 6 times 9 is 114. And 7 times 9 is 133. 133. And this is just to clarify this. This is 114. Okay. And 8 times 9, which is 152. And 8 times 19, and all these are times 19. And 9 times 19, so each one of these 1, 2, 3, 4, 5, 6, 7, 8, 9 times 19 is 171. And those are all of my multiples of 19 to then utilize the actual longhand division, which is this guy here. So we're going to use that to actually check our work, not having rounded anything. So 19, if we look back, goes into 7. No, goes into 7D. Well, I see this 4 here. 4 times 19 is 76. So I'm going to put a 4 there because it goes into 7D. 4 times 19 is 76. Oops, hang on. Let's go backwards here. Let's check this. 70 and 76, so it'll go into it 3 times. Excuse me, not 4 times. 3 times 19, if we look back here, is 57. So I'm going to put 57 down here and take that away. Cross that out, turn this to 6. 10 minus 7 is 3. 6 minus 5 is 1. Carry down the 0. And we're now looking for something going into it 130 times. And the closest one without going over is the number 6. 7 is 133, and that's just a hair too big, so 6 is 114. So we're going to go into it 6 times, which we said is 114. We take that away. I'm left with 16. Carry down the 7, so 167 is what I'm looking for now, which would be 8, because 9 is just slightly too big, so that's 8, 152. So 8 brings us 152, and when we finish this up, we have a 2 here, and we look from before, it was an 8 that goes in 152 times, so it's another 8 exactly. 152, and you'll notice that this gives us a 0 remainder. So my answer is 70,072 divided by 19 is equal to 3688, and no remainder, so that's the exact answer. So what we're doing now is we're using an estimation from before where we round each of these numbers, and then we'll actually use the algorithm. And once it hits a certain point, we understand the setup of the algorithm. At that point, then I'm fine with using a calculator to double check it. So again, this is just making sure that we can get relatively close with our estimate, so we have a ballpark answer. So 14,175, I'm going to round to 14,000. I'm going to round it down a hair. Divided by 315, I'm going to round to 300. So we've got a bunch of zeros. Remember, that's the same thing as saying 14 on top and then 3 zeros over 3 on bottom and then 2 zeros. I can cross out my zeros and I'm left with 140 over 3, right? 140 over 3. Well, 3, so 3 would go into 14 4 times, right? 140 divided by 3 would go in 4 times. That's a 12, 20 remainder, right? And that would be just under a 7. It would be a 6 and then repeating. So I'm going to say it's probably somewhere around, and if we look, keep in mind, we rounded this one down and we rounded this one down. So it's pretty close to 47. I'm going to go ahead and round it up to 47. Should be around 47-ish, and we're actually going to go ahead and test it on our calculator. 14,175 divided by 315 is 45. That's our exact answer. Okay. Same thing is true for each of these here. All we're going to do is we're going to estimate, and then we're going to actually divide it. So this one here, I'm going to round to 480,000 divided by, I'm going to round this one to 80. You'll see why in a minute. 0 and 0. So I'm left with 48000, right? 1, 2, 3 zeros over an 8 and no zeros. So what's 48 divided by 8? 48 divided by 8 is a 6. And then I have 3 zeros left over. So I'm going to say it's about, squiggles here, about 6,000. That's my guess. My next one here, I'm looking at 280 and 30, right? 280,000 over 30. Again, cross out my zeros. I'm left with 2, 8, and then 3 zeros on the top. 1, 2, 3, and just a 3 on the bottom. 3 goes into 28 9 times, right? That's 27. So I'm going to say it's a 9, and then 1, 2, 3 zeros with a little more. So I'm going to say it's a little bit more than 9,000, but it's should be around 9,000, give or take, right? Looking at this next one here, we've got a really big number in the millions here. So I'm going to round that to 2.3 million, or 2, and then a 3, and then the rest zeros. Over, I'm going to round this to, let's make the math even a little easier on this. If I rounded this to 24 instead, that'd be perfect. Answers in here. Let's take a look at this. 24. I know I'm rounding it up even higher, and I'm rounding this one up even higher than to 40, but you'll see in a second. And when I cross out my zeros, I have 24, and then 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros over just a 4. 24. 4 goes into 24 6 times. I know it's going to be less than this, but it's going to be 6 times, and then it's going to be 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. But I'm saying should be somewhere in the ballpark of around 60-ish, 60,000. Okay. Okay, number 4. I've got 952,448 divided by 112. I'm going to round each of these. I'm around 952,000 to 950,000. 950, 1, 2, 3. And for the moment, just to make the math exceptionally easy, I'm going to go ahead and round this to just 100. If I cross out the zeros here and here, I'm left with 9500 over 1, or it should be around 9,500. Should be somewhere around that 9,500-ish mark. And then the last one here is a big number. I'm going to round that one to 2 million. Over 245, I'm going to round that to 250. And if we do zeros here, you'll notice I have a big number on top, 2, and then I got, 5 zeros. 1, 2, 3, 4, 5 out of 25. Well, I can also use this and scale it up. So if I scaled each of these up, if I multiplied the top and the bottom by 4s, the top would be an 8, and then 1, 2, 3, 4, 5 zeros. 3, 4, 5, right? 1, 2, 3, 4, 5, yeah. And the bottom, if I multiplied the bottom by 4, I'd get 100. And now I have more zeros to be able to cancel. and I'm left with somewhere around 8,000, give or take. And so all we're going to do now is we're going to use our calculators. And again, you can do it longhand since I've shown it to you longhand and you understand the process behind it. I'm much more interested personally on you guys coming up with the estimates of stuff to make sure that you're in the right ballpark. So we're going to go ahead and use our calculators on this for each one of these to get the exact answer. So 484,692 divided by 78 is exactly, and there's the equal sign, not the squiggly sign, is exactly 6,214. This next one here is 281,886 divided by 33. That comes out to 2,481.39 repeating. And let's take a look what happened here. 280. Oh, just kidding. This should be 3 times 9 is 27, and then should be a couple zeros. What did we do here? This one seems off. 281 and 33. Let me double check that. 886 divided by 33. Oh, that's why. Would help if I had put it. See, and this is why we double check stuff, because this number seems way off, and it is. This number is way off. I must have left off one of the 8s on accident on my calculator here. So 281,886 divided by 33, I actually get 8,542 exactly. That's the exact answer. And see, this is where, again, this estimation, this ballpark, helped me double check stuff, because we are used to putting things on the calculator and just taking it at face value. Oh, yep, that's what it is. That's what the calculator said. But again, we did the estimation ahead of time. We know what it should be around. It should be around 9,000, which makes sense logically. So when I got that 2,400, I took a moment and backtracked stuff and went, whoa, something seems off. And what was off was I just put in the wrong number on my calculator. So that happens. And again, it's important to be smarter than the calculator. So that's where we did this estimation. So I have 2,295,517 divided by 37. This is my third one. I get exactly 62,000. Exactly 62,041. 62,041. My fourth one here, I have 952,448 divided by 112, and I get exactly 8,504. 8504. And my last one, I have 1,823,535 divided by 245, and I get exactly 7,443. So if you notice, each one of these, this is relatively close. This is relatively close. Since we double checked that, that is relatively close. That is relatively close. And that is relatively close, all given the size. Yes, this one's off by 2,000 something, but if we look, that's in the 60,000 mark, whereas this is only off by about 200 in the thousands mark, right? This is off by probably the most here, because I did some mental rounding with that and did 27 instead of 28 for this guy, which is where I got 9. So we're looking at about 450-ish off. Number 4, you'll notice we're a little farther off. Again, we rounded this down considerably, which is why we're off by that about 1,000 in that. So that's not perfect, and that's because we rounded it way down to make the math super easy instead of doing 110, which would be a little more difficult. And again, remember, estimating is just quick mental math on that. And we look at this last one, we're not off by that much considering that it's in the thousands, and we're off by a handful of hundreds. And again, we rounded this one up and this one up considerably. 1.8 million, we rounded to 2 million, which is a pretty big chunk of rounding that we did there. So all in all being said, we were well within the ballpark of each one. We weren't way off and wildly off, with the exception of number 2, which was only because, like I said, I plugged that in the wrong numbers on my calculator. And it's a good I kept that in here on purpose because it's a good reminder that even I make mistakes. You know, pushing buttons on a calculator, everybody has the potential to push the wrong number or accidentally like omit or leave off a number. So I thought that was important, and I didn't try to like delete that out of this video because, you know, we all make mistakes, myself included. Big part of making, you know, being an adult is taking ownership of that mistake and finding ways to fix it in the future. So for me, I would simply double check my numbers before I'd hit the equals, and that would be one way to like try to not have that problem in the future. With that being said, we are done with all of our classwork and on to problem set.